Okay guys, we are doing, I say that a lot, the okay guys, but anyway, I don't know how else to start these videos, but we are doing subtracting polynomials today. So yesterday we did the adding. Today we are subtracting, and this should be fairly straightforward. It's similar to yesterday. If we look at it, we're going to distribute the negative or the subtract, and then we're going to collect like terms. Okay, sorry it ran off there. So we distribute the negative and collect the like terms. So easiest way to do this is just kind of give an example. So if I had 3n cubed minus 5n plus n squared, remember that parentheses is just saying, hey, here's one polynomial. This one happens to be a trinomial of the third degree. Okay, minus negative 8n squared plus 3n cubed minus n. Okay, so if it was a plus one, we could just go ahead and start collecting like terms. But because this minus here is saying that we need to take and subtract everything in here. So what we're going to do is we're going to take this negative and we're going to distribute it through. So I'm going to rewrite this. As soon as I distribute this negative, these parentheses aren't really necessary, so I'm going to write 3n cubed minus 5n plus n squared. Okay, I distribute that negative. I have a negative 8n squared. So a double negative is a positive 8n squared. I have a negative positive 3n, so minus 3n. And then I have a minus a negative n. So minus a negative is the same thing as saying plus n. Okay, so I distribute that negative. Now it's just a matter of collecting like terms. So I have 3n cubed and negative 3n cubed. I have negative 5n and n. And I also have n squared and positive 8n squared. So if I look at this, 3n cubed minus 3n cubed is 0n cubed, which is just 0. So really, those two kind of just cancel each other out. Then I have a negative 5n plus n. That's going to be a negative 4n. And then what's in front of this n squared? That's a 1. So 1n squared plus 8n squared is 9n squared. Okay, so very similar to yesterday, just have to distribute that negative. Okay. Let's do g cubed minus 2g squared plus 5g plus 6 minus g squared plus 2g. So in this case, we're taking 4 terms, and if we have a 4-term polynomial, it's just called a polynomial. It doesn't have a fancy name. And we're subtracting a 2-term polynomial, which is called a binomial. Okay, we're going to distribute this negative. So I have g cubed minus 2g squared plus 5g plus 6 minus 9, or sorry, that's a g. I can read my writing. Minus g squared minus 2g. Okay. Let's see. I have a g squared and a g squared, and I have a g and another g. All those other ones, the g cubed and the 6, there's nothing that goes with them, so they just stay the same. So g cubed, negative 2, that's a g, not a q, 2g squared, and negative g squared is negative 3g squared. Positive 5g, negative 2g is positive 3g. And then don't forget this 6 plus 6. Okay, and we're just going to do one more on here because we can. X squared y minus 3x squared plus y minus 4x squared minus 2y plus 6xy. Okay, start by distributing this negative. So that would give me x squared y minus 3x squared plus y minus 4x squared plus 2y minus 6xy. The 4 became a negative, a double negative became a positive 2y, and then a negative and a positive is our negative. Okay, trying to find like terms. I need something that has x squared y. This has an x and a y, but remember the exponents have to match, so those are not like terms. I have a negative 3x squared and a negative 4x squared. They're both x squared, so here's a pair of like terms. And then I have a y and a 2y. Okay, so again we have a situation where we have two terms that didn't go together and they don't have any like terms, so they just stay the same. So x squared y, negative 3 and negative 4 is negative 7x squared. 1y plus 2y is 3y, and then minus 6xy. Okay, the order doesn't matter, I just kind of work left to right. Okay, so you guys, your assignment is on page 494, number 13, 15, 35, and 43. Okay, I hope you guys have a great day, and I will get the next video posted either tomorrow or Thursday. I'm trying to post them a little earlier, so okay, have a great day. Bye.